The gradient of a straight line is a measurement of the steepness of that line. Now we need somehow to find a mathematical equation or a mathematical formula with which to indicate the steepness. What will make one angle or one incline steeper than another? And what we do is to define 2 points on that line, a point there and another point there. Since we are working with the 2 points, each of them will have an x and a y coordinate. And then obviously, if you think about the logic behind this, to find the vertical distance that these two lines are away from each other, we'll subtract their y coordinates. That will give us the vertical distance, how much higher is the one than the other. And to find out the horizontal distance that they are away from each other, we'll subtract the x coordinates from one another. And then we can divide those two. So then we say delta y over delta x, which is just a shorthand version. Delta, that little triangle, is a Greek symbol meaning difference. So the vertical change divided by the horizontal change gives us the gradient, and we can actually define it with that formula there, and it gives us a fraction. We've got a value, a numerator, and another value, a denominator, and the fraction will give us a measure of the inclination or the steepness of that inclination. So it's very important that you grasp this concept. The gradient is all about the vertical distance divided by the horizontal distance between 2 points. You need the 2 points, otherwise you won't be able to find out what is the distance that they are away from each other, vertically or horizontally. The gradient is determined between points on the curve. So then suddenly they refer to a curve, which can be the name that we use for a straight line, strange as though it may seem, but also a curve could be like a parabola or some kind of a curve. Any graph that you can think of could be a curve, but again they are stressing the important point that we need points. We need at least the 2 points to find the gradient. Now the following is known regarding straight lines. Then we jump back to straight lines again. The gradient is constant. What that means is, if you go back to that straight line graph that we've had up there, if you were to find the gradient between that point and that point, or you were to find the gradient between those 2 points there, or even if you were to find the gradient between that point and that point up there, you'll always find the same gradient for the straight line. No matter where you are, no matter which 2 points you choose for a straight line, you always get a constant gradient. Then when the fraction that you find is bigger than 0, in other words m is a positive value, the ascending or the straight line would be called an ascending straight line, because what happens is we go to the right on x, and at the same time the straight line moves upwards. Then we say it's an ascending straight line. It's got a positive gradient, and that angle that it makes with the x-axis is an acute angle. When m is smaller than 0, now we've got a negative gradient. Then as we move to the right on x, the line would actually move downwards. So now it's a descending line, and that angle there that is being made with the x-axis, positive x-axis in the first quadrant, is an obtuse angle. It's bigger than 90 degrees. That's for a negative gradient. When m is equal to 0, we are referring to a horizontal straight line. Now just think about this. The equation of a straight line would be y equal to mx plus c. So if you have y is equal to 0x plus c, because they said m is equal to 0, the gradient is equal to 0, and that line might go through the point 3 on the y-axis there. Then the gradient part of that formula will fall away, and we would simply have y is equal to 3, because the 3 also refers to the y-intercept. So then when m is equal to 0, the gradient is equal to 0, we just have a horizontal line. When m is indefinite, now this is the other exclusion that you need to be aware of. When m is indefinite, it means a vertical straight line. And where this comes from is, let's say that point is x equal to 4. Then that point up there would have a 4 as the x coordinate, and the point down at the bottom would also have 4 as the x coordinate. And when you look at the formula to determine the gradient, below the line you would have x2 minus x1. But in this case you'll have 4 minus 4, or whatever the value is, minus itself, and you'd end up with a 0 below the line. So when the gradient cannot be determined because of the 0 below the line, that function would then, or the graph would just be a vertical straight line going through the point whatever on the x-axis. So this one will have an equation x is equal to 4. So that's not even closely related to the formula for a straight line graph, at least the previous one we had y is equal to 0x plus c. This one is not even y equals anything, it's just x equals the value, but that is a vertical straight line, and it points to the fact that we have an undefined gradient. It cannot be determined. The gradient of a straight line can be calculated without difficulty because it is constant. So just going back to that drawing that we've had right at the beginning. If, for instance, we find the gradient between those 2 points there, say, we can assume that it will be the same anywhere on the straight line. So even between those 2 points, the gradient would be the same as what we've calculated there. The gradient is constant, and therefore the gradient of a straight line can be calculated with ease.